Hello, guys, and welcome to the second episode of my Delphi programming series here on YouTube. My name is Lucian Blichnoot, and today we are looking at variables and data types. Now, you might remember in our previous episode that we did this show message with this little string thingy going on here. And I told you, well, don't worry about this for now because we'll have a look at this later. Now is later, so we're going to have a look at it. So I set up this little table thingy here so I can quickly show you guys. So we're going to have a talk about primitive data types. Now, data types come in many different forms and across all different programming languages. These will mostly be available in Delphi, but a lot of them you'll find in other programming languages such as C Sharp, C++, Java, Python, any programming language you can imagine. They will have primitive data types. And these are just what we call them in Delphi. They might be called something else in there in other programming languages. So let's just quickly have a look here. So what is a variable? Now you might be, in your IC class and your teacher tells you, we've got variables and everything, and you might wonder, well, what's a variable? And they will sometimes ask this in the exams. Now, a variable is simply a placeholder in memory. All it is a place to store some information or some data, some value in your computer's memory and use it later on. Now, this you can just see this as a box on a shelf, where the shelf is your computer's memory. You place something in that box, put it on the shelf, and you leave it there. And later you can come back, you can take off that box, it will have a name, it'll have its data type, and you can retrieve that information, that data you stored in that box, you can retrieve at a later time. So that is all a variable is, and they are very, very useful. You can see variables in maths as well. If you grade 10 now, you might know we've been using with, x's and variables and whatever. That variable, that x, we use in algebra. That is literally the exact definition of this. It is simply a placeholder for anything you want to store in that value, anything you want to replace x with. That is what a variable is in programming. Now, we're going to have a look at a few of the data types you might encounter while using Delphi and some interesting information regarding them. So the first one and the smallest one is a byte. Now a byte, as its name suggests, takes up one single byte in your memory, and it has a range of 0 to 255. All of the gamers out there will know that you have RGB LEDs and everything, and their brightness and their color spectrums range from 0 to 255, if you did not know that. So the RGB range is from 0 to 255. So that's where that comes from. It's the smallest data type at the moment you can use in Delphi, just 0 to 255. Then we have a short int. We never really use this, but it's just negative 127 to positive 127. It's pretty useless. It's a very small range, but um, if you obviously you need to know that using data types depends on your need for them or your needs. Because let's just say you want to store the class register and you want to store the class name. Like in our school, we have, A for Afrikaans and E for English and then the class number. So that'll never be more than 10 digits. So you can obviously use a byte to store any value from 0 to 255. So whenever you can, use the most appropriate data type to store the value you are going to use. Obviously, you don't want to use 255 when you're going to use with work with large numbers, large values, because then you're going to get truncation errors and overflow, and it's just a big mess. So whenever you can, use an integer, which we'll get to now, but it all depends on your application and what you want to do. Next, we have Word. Now, really ironic, we're working in Word here, but Word we never use. I've never used it, but it's just 0 to 65,535, and it occupies 2 bytes of memory. So, it's not too demanding on your memory, but it just stores up to just below 100K. And then next we have the infamous integer. Now integer you're going to use a lot. Integers take up 4 bytes of memory and they can store up to negative 2 billion 150 million to positive 2 billion 150 million. So really large numbers. And in real world applications, this isn't even enough to store the amount of data and the large volume of things they use. So very interesting. Then we have in64. Now this is just like a long. If you've worked with other programming languages, this would be called a long, and this would be called an int, and this would be shortened. So longs are just 64-bit versions of integers. So they take up 8 bytes of memory, pretty large, and they go from negative 9 times 10 to the power of 18, really big number. I don't know what it is, to positive 9 times 10 to the power 18, really large numbers. And then next up, we have floats and reals. Now, up until here, we've worked with integers and just normal, um, natural numbers, nothing really that has decimals and commas and weird stuff in it. In Delphi, if you want to store a currency or any decimal value like pi, you will need to use a float. Now, a float or a real uh, takes up 8 bytes of memory. It's pretty large, and it can store incredibly small values. Negative, uh, 10 to the power negative 324 is incredibly small. So it can take really, 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 really small values with decimals or really large ones. 1.7 times 10 to the power 308, really large numbers. So it's pretty impossible for you to exceed this value if you're going to use it in your application. So don't ever worry about truncation or overflow when you're using these really large values. So remember, this is only used for currencies or decimals like pi or anything of the sort. Now you can store integers in floats, but you can't do it the other way around. You can't store a real in an integer because you'll note that there's 8 bytes of memory that this takes up, and an integer can only take 4. So you're going to get some sort of error, and I'll demonstrate that later. But you can store an integer in a float with decimals. So that's really useful to know. The next up, we have the text-based uh, data types. So these were like number-based and decimal-based. Now we're coming to data types with text. Now the smallest single bit of text you can get is called a character or a char in Delphi, and it occupies 1 byte in memory. Now, examples would be, notice that we use single quotes to store any text value in Delphi. So it can be A, it can be B, it can be anything on your keyboard. Literally, you could just type in whatever's on your keyboard, and it will be able to store that in a char. So I say here it's any ASCII character. Now, if you don't know what ASCII is, ASCII stands for the American Standard Code for Information Interchange. So it's simply like an international standard for characters we can use in um, applications. So all computers will be able to understand or read the binary of these ASCII characters and identify them as single ones of individual characters. So if you don't know what ASCII is, just go Google ASCII and it'll show you an entire table with all the available characters you can use and store in a char. Next, we have a string. So strings are very important because we use them a lot. A string is any combination. I notice I bolded combination there because a string can essentially be a single character. But why would you want to store a string, which, if I'm correct, takes like 8 or 4 bytes of memory? It depends. Why would you want to store a single character in such a large container? It'll be useless. It'll be like storing a cricket ball in a huge box meant for a fridge or whatever. It's pointless. It's stupid. It wastes memory. From a coding point of view, it is wasteful. You don't want to do it. So whenever you can, store combinations of characters, more than one of these together in a string, like John, Saviwe, oof, whatever it is. you're going to want to store it in a string. And then next up, this isn't text-based, but we have booleans. We have ones or zeros. It takes up 1 byte in memory because it is just literally a 0 and a 1, which we've noticed here. um, so booleans are true or false values, zeros or ones. Literally, they are binary at their core. So any Boolean expression would be able to be stored in a Boolean. And now we're getting to some conversions. Now, we've talked how we can store integers in floats, but not floats in integers. So how does that work? How do you change? Let's say you want to get input from the user from a text box and they type in the letter or the number 4. Now you need to remember that all inputs will most probably be text-based. Anything I've put in here, especially like this, when the user enters a value, this will be in a text format. That is not a number. That is a character. Remember, that's literally a character. That's not the number 6. That is a character for 6. So what if we want to use that and make calculations? It's very important to know how to change between data types. And these are the most common you'll find in Delphi. So we've got a string to an integer. So this would be an example where you ask a user for inputs. They use an edit box. I'll show you this everything to you later. But that text will be in uh, a character or string. So we want to convert that to an integer. And you do that with a string to int function. So you pass in the string you want to change between these brackets. So you can say like this and just say 2 like that, and that will spit out on the other side the actual integer for 2, which will be stored in an integer variable. So that's an example. I'll show everything later. Then next we have integer to strings. So let's say we did our calculation and we have a string, an integer value now, but we want to display that to the user. Now you can't just display an integer because it's a number. The computer will know what to do. The application will just break. So you need to convert that integer to a string to be able to use it. And we do that with int to string. It's very self-explanatory code, int to string, basic. Then we have string to float. So imagine we want to tell the user, okay, we're going to figure out the circumference of a circle. Tell us how many decimals of pi you want to use. So then the user can put in, 3,14, 5, whatever, up until whatever decimal they want, but that value would be a float. That value they enter in the edit box will be a string. So if we want to change that to a float to be able to use it in calculations, remember the only data types you can use in calculations would be these. So you can't use these in calculations. So you need to convert it to either an integer, but you obviously can't store a decimal in an integer, so it has to be a float. Very important. And then you can do your calculation, whatever, but then you want to probably display, what you just figured out. You want to display the circumference. So you need to convert a float to a string. And you do that in 2 different ways. I'll show you these ways now, like later. We have float to string, self-explanatory, or float to string f. That f stands for format. So this will be a specific format you want to display the float in. So say like a currency, or you want certain decimals, certain amount of decimals, uh, things like that. And I'll show you how to use it. Then we have float to integer. And this is pretty useful. Let's say you just want to round that float value. You just want to, have no decimals. You just want to display a natural number. So then you can just use float to integer and then trunc. So this will literally just chop off everything past the decimal. So let's say it's 3,141, and then it'll just chop off that 141 and just say 3. So it is dangerous to use this because if you're working with sensitive data, you need to have decimals, or otherwise it'll affect the accuracy. Don't really use this unless you're going to display it to the user, because when you truncate, it's like, simplifying too early in a calculation. The answer will probably be affected by the rounding. So just bear that in mind. So that's enough theory for now. I'm getting bored. Let's get into some coding. So let's just remove this. Just a quick reminder, when you're in your coding screen like this, you can just click here on the design and press that, or you can press F12 and it'll switch between the two. So let's add a few things here. I'm going to add a panel. So you just type in panel. Also note that you can find all these components in the standard box here. So these are all the different components you get that are like standard basic components. And as you get down, you get more, weird stuff like string grids and images and shapes. Don't have to worry about that now. So we're just going to have a panel, click on it, drag it on, and let's change some of its attributes. So I'm going to make it a bit bigger. I'm going to remove this caption. So let's go down to caption. I'm going to remove it so it's clear. Then I'm going to go down to its name field, and let's call it PNL. PNL is the prefix for panels. So this is PNL out, because this will be our output to the user. And this button, we're going to leave as click me, but we're going to change the name to BTN click of BTN in. So this will be our input. So when we click on this, it'll create a new event handler for us. So now we can do whatever we want. Let's prompt the user to enter some data. So let's get an edit, edit. Now this is just a text box. So the user can enter anything they want in here and we'll do some stuff. So let's make this EDT. EDT is a prefix for edits. So let's make this edit text. There we go. So now we have everything set up. Let's just clear the text. Now notice edit boxes have a text property, and the text property is literally what's in the edit box. So if we change this to anything we want, so that'll be what the user enters. So we're going to use that in our code to do some stuff. Okay, so there we go. Let's do some things. Let's say we want to add integer and retrieve an integer and say multiply it with 10 and do some calculations and display it back to the user. And we're going to store this in variables. Now, variables can be used in two different ways. They can be local, like I'm showing to you now. In the procedure itself, above the begin, you can add var, this stands for variables, and you can add your variables. But you can also have global variables. The global variables come under the private section. And I'll go into more details about this later on. Just know that we're going to do local variables for now. So I'm just going to say s input. S, the little s there is the prefix for strings. And you need to declare the variable with a colon and then string. There we go. So now we've declared our input variable. And let's declare our I value. So I value. I, so my thing stands for integer. So we're going to say this as an integer. There we go. So now let's get our inputs. To make a comment, you just press 2 forward slashes next to each other and you get a comment. So let's say input. So we're going to say that s input will be equal. Now use a colon and an equal sign, not just an equal sign. So remember the colon equals, and that will be edt, our edit, dot text. So we're retrieving the text property from our edit box and storing that in our little box we called s input. Now we want to convert s input to an integer. So we say I value, and that will equal string, we want to convert the string to an integer. So we say string to int. There we go. And we pass in a string, which is s input. There we go. Remember the semicolons at the end. Now we can do any calculation. We can say I value equals I value. Let's say we multiply it by 100. Okay, so it'll do this calculation and then only then store that value in I value. So it's a bit confusing, this I value equals I value. Just remember that it'll always execute the lines to the right and then store that value in the like variable on the left. And now we want to display that again. So we're going to use the panel. So we're going to say PNL out dot caption. The caption is the text part of the panel equals, and they're going to say int to string I value because we want to change the integer to a string. And there we go. Now I can quickly, so that's part of the input. That's part of the processing. And this is part of the output. Let's run this and see what it does. So let's put in the value 1. Remember, this is text. I'm going to click this, and it will display that value times 100. And yes, it does. So let's say 12. There you go. But now, what happens when I add a decimal? Let's make it 12.0. Ooh, that's a nasty little error. 12.0 is not a valid integer value. So notice how you can't use, floats and string like floats for integers because it just won't work. You'll get nasty errors like this one. But we can change that if we say R value is equal to a real. So you get real 48 or a real which is a double. Just use the real. Well, now instead of I value, we're going to use R value. Now R value is going to equal string to float. And they're going to use edit text.text. There you go. So it's the same as input, or we can just say, now this is why variables are useful. Just say s input. There we go. Now we're going to use R value to do the calculation. So we're going to say R value equals, let's say R value, let's say times 200 to 200.25, some weird number. And notice you're going to use points. Points to show the decimals, not commas. Commas won't work. You need to use points. And then PNL outer caption, I'm just going to get rid of this one because we only want to display the R value. So R value, or let's say PNL out dot caption equals, and then we're going to say, remember, we want to change the floats to a string. So this is important. So we're going to say float to string. We're just going to do this the normal way and pass in our variable R value. There we go. And we actually don't want to do this because we're going to get an error. So now we only have our S input, R value. We do the calculation for R value and we get the output. So let's run this real quick. Now, let's enter an integer and see what happens. It just displays 200.25, exactly what we said. But what if we had 400.5? Okay, let's make this a decimal. Let's say 1.5. Now what will happen? You notice how there's 3 decimals and these decimals are not limited. We can say 1.5, whatever, and it'll just keep going. Notice that. So we can add just normal integers to this calculation and it'll work, or we can add an infinite amount of decimals. Not infinite, but large, and you'll get no errors. It'll work. Now, what if we don't want these like excessive decimals. Now that's where floater string f comes in. Now a few other ways of doing this. So let's go here and let's change it to floater string f and then a comma, brackets. So the first value you enter is the value you want to change, which now changes our value, our case. Then you add a comma. Now you add the formats. So the format is FF, and then you get a whole list of formats. Now, just don't worry about the rest for now. We're just going to use FF fixed. Then we need to add the amounts of digits you want before the comma, which we can say is just 6. That'll be 6 million, or 1 million actually. So you can go to values up to a million. And then this last one is the amount of digits you want after the decimal, which in our case, let's make it 2. So let's say this is like a currency. Let's actually make this currency, FF currency. You'll quickly realize why this is very useful. So let's run this quick. So let's enter 12.5. Now click me and notice how we now have a very nice rounded value with up to 6 digits on this side of the comma and 2 digits beside the comma, after the comma. So that is what this part of the code is doing. Let me just quickly minimize this. That is what that part of the code is doing. That represents after the comma, and this is before the comma. So 6 digits before and 2 after. And this is just the format version. So let's make this FF fixed, and you'll quickly see the difference. So this displays it as a currency, and then FF fixed just shows it as a number, normal number. So let's 12.5 or 12.4, doesn't matter. You see, it's just a normal rounded number. There we go. That is pretty much the basic introduction to variables and data types. So we've quickly learned how to, declare our variables. In order to use variables, you need to declare them first, and we declare them over here, which is above the begin, or you can declare them over here under the private section. We'll get into details of the difference between declaring over above, like under private, and in the procedure itself. Just know that you can use variables to store information. Different variables have different data types. We have strings, integers, reals, floats, a ton of them, and we can change between them. We can change between all these values: strings to integers, integers to strings, strings to floats, whatever. And that'll be the most important knowledge at the moment that you can use and apply in your applications. So I hope that you enjoyed this video. Please like and subscribe. Let me know, how you found the video, what changes you'd like to see, what you want me to make videos on later on. So I'll try and reply to your comments. And yeah, I can't wait to see what you guys think. And I hope this video helped. Thank you very much and goodbye.